there are a few differences between team sports and individual sports for predictive purposes. In team sports, we have different data aggregation problems. We also have conceptual problems as to what is a team and what it consists of. And finally, we can also have different prediction goals. So, first of all, we're going to talk about stat aggregation. So, in team sports, we have teams which are composed of players, and it's not clear which stats are relevant. I mean, we could only go ahead and use team stats, but we might as well use player stats and then aggregate them and on the team level. Obviously, using player stats can provide finer detail, but it can, in theory, can be more informative. However, it's also more complicated. So, for example, if we had, let's say, 50 different stats that describe a team, in soccer, we would end up with 50 different stats for each player, which would mean that we have to deal with over 500 stats in total for a single team. So this brings us to the next topic of what is a team anyway? Conceptually, a team doesn't stay the same throughout time. All right, so a sports team in 1960 in the same club 50 years ahead, it's just not the same club. There are, however, a few constants, one obviously being the country, but you also might have things such as the fact that many clubs which are on the top quite often stay on the top, and you can also have things such as the disposable income that teams have in order for transfers, etc. So, for example, rich clubs in the past are usually rich clubs in the future. But in the end of the day, a team is a collection of players, the coach, the facilities, etc. And this can actually change from season to season. And if the team and the coach are more or less the same from season to season, then using team stats looks like reasonable. But if that's not the case, we might actually have to go and use player stats. Another issue in team sports is transfers. So if a player gets transferred from a different team, we might not have stats for this player, or we might have stats which are not relevant, maybe because the player was playing in a slightly different role in the old team. The worst case scenario, and a very good example of that, is a World Cup and other international tournaments where basically there are no relevant stats in many cases. So, for example, for the Football World Cup, it takes place every 4 years, and many of the international teams can look quite different from year to year. And also the training philosophy and the gaming, the style of the teams might change from one tournament to the next because the coach changes alongside the players. So we can just get the stats of those players from their actual teams they play in during the league, and just transfer these, just get these stats and use them in our model straight away. It's quite likely that an athlete that's performing spectacularly well within his club doesn't perform well when playing for his country. And we've seen this happening many times in the future, and also vice versa. Sometimes you get some one-hit wonders in World Cups where you might have someone who's not very well known in the past, and suddenly he performs spectacularly well during the tournament. So obviously another thing with team sports is that not all of them are created equal. Some sports are easier for predictive modeling, some other ones are more difficult. Probably football/soccer is a nightmare scenario because you have lots of players, it's a high variance sport, and all these players interact dynamically on the pitch, whereas baseball and cricket are easier to predict because the interactions between the players are more constrained in a sense. I mean, it's no coincidence that basically sports analytics as a field was kickstarted by Moneyball. Another issue which arises more often in team sports than individual sports is that of the prediction goal. So in many team sports, we're not facing a win-lose situation, but we might be facing different outcomes, for example, win, lose, or draw, which makes things more complicated. Not only because it's more difficult to predict more outcomes, but also because some of the metrics we've seen, such as the accuracy, stop being as informative as when you only have two outcomes. The same can be said for precision and recall and other metrics as well. So for that reason, sometimes it can be more interesting to predict other things, for example, the points that the team will score or the point difference. And there has been also research in some completely different takes, such as just predicting the position on the league table straight away, and not actually predict outcomes, predict what the league table will look like in the end of the season.